If humanity vanished today, it would take roughly 4 million years for Earth to completely obliterate our physical legacy. This destruction is fueled by the relentless movement of plate tectonics, which pull the crust into the mantle to be melted, and erosion, which slowly grinds mountains into sand. We find ancient ruins because they are incredibly recent on a planetary scale. The pyramids of Giza have stood for millennia, but even they are transient against the backdrop of deep time. Because the planet is so efficient at destroying physical history, our standard archaeological tools are unable to see the massive spans of time that preceded our own arrival. In 2018, astrophysicist Adam Frank and NASA's Gavin Schmidt proposed a framework for this missing history called the Silurian Hypothesis. They wanted to know if an advanced civilization thrived 250 million years ago on the supercontinent of Pangaea. What surviving evidence could we actually detect today? After hundreds of millions of years, even massive cities built with concrete and steel would be ground to unidentifiable dust. To find a lost civilization from the deep past, scientists must look past physical ruins and hunt for invisible, microscopic geochemical ghosts. While our buildings will eventually vanish, the act of industrialization permanently alters the global chemical record in ways that can persist for eons. This graph illustrates the Seuss effect. Burning fossil fuels releases ancient carbon into the atmosphere, causing a sudden and unnatural shift in the ratio of carbon-13 to carbon-12. Then there are synthetic isotopes. Elements like plutonium-244 never occur naturally on Earth. Their presence in the rock record provides unambiguous proof of nuclear technology. We also leave behind geochemical scars from mass agriculture. Global spikes in nitrogen and phosphorus characterize our industrial farming and are detectable in the soil for millions of years. Even our plastics leave a mark. As these synthetic polymers degrade, they leave behind detectable hydrocarbon residues that become a permanent part of the planet's sediment. These three markers, carbon anomalies, synthetic isotopes, and agricultural scars, provide the technical checklist required to identify an advanced civilization in the deep past. If we apply this checklist to the rock layers of Pangaea, we can begin to see if anything else once called this planet home. Geologists have found massive carbon spikes and evidence of extreme global warming within these rock layers, dating back 252 million years. But these anomalies trace back to the Siberian Traps, a massive volcanic event that released carbon naturally rather than through an industrial source. Furthermore, we find no synthetic isotopes like plutonium-244 and no unnatural concentrations of metals that would indicate a global manufacturing presence during the Permian. While the Earth is excellent at erasing its history, the current chemical record suggests that no industrial predecessors occupied Pangaea before us. Even without finding an ancient Earth civilization, the Silurian Hypothesis provided a new methodology for the field of astrobiology. Scientists use this list of industrial markers, like atmospheric pollution and unnatural isotopes, to scan exoplanets and distant moons for advanced life. Hunting for ghosts on Pangaea provided the specific technical criteria we now use to search for intelligence among the stars. There is a final, profound irony here. By building our own civilization, we are currently laying down the exact chemical anomalies Frank and Schmidt were searching for. We are writing the Anthropocene into the rock, a layer defined by rapid carbon shifts, radioactive fallout, and global microplastics. In 250 million years, all of human history, our wars, our art, and our cities, will be compressed into this single microscopic line of strange chemistry. In deep geological time, a civilization is remembered only by the invisible chemical ghost it leaves behind in the stone.